Hi everyone. Today we're going to learn implicit differentiation. Also something really important you need to know for university. So we're learning to find the derivative of a function that is implicitly defined. So that's probably a word that we haven't used in math before. We'll see what that means. And we're learning to find the slope of a tangent at a specific point of a function that is implicitly defined. So in the chapter we just did on the rules, our functions were always written as y is some function of x. So y was on the left side and everything on the right side was in terms of x. And that's called the function being explicitly defined. Okay, so y equals some function of x. But functions can also be defined implicitly. So 3xy equals 12 is an example where we don't have y by itself. In this one it would be easy to get y by itself. And we could then use the power rule would work for this one. But in one like this, where it's 2xy minus y cubed equals 4, it would be harder to get y by itself because we have the y cubed and the y. So there is a way to find the slope of the tangent implicitly. So we're going to find the slope of the tangent to the circle x squared plus y squared equals 25. And we'll find it in general, and then we'll find it specifically at the point 3, -4. But because we can compare it to something we know is correct. So we went back to this example way at the beginning when we were first defining what a derivative was. So we knew that for circles, a property of circles was that the tangent was always perpendicular to the radius. So here's my radius from the center to the outside. And we can see here that the slope of the radius is negative. 1, 2, 3, 4, -4/3, rise over run. Okay, oops, -4/3, which is the rise over the run. So that would mean that the slope of the tangent, if I go down a bit further then, should be the negative reciprocal based on what we learned in grade 9. So it should be 3/4. So from here we would go up 1, 2, 3 over 1, 2, 3, 4, down 1, 2, 3, 1, 2, 3, 4, and this should be our tangent drawn in here. And again, we're just using geometric properties to do that rather than calculus, but we want to be able to use calculus and then this time implicitly instead of explicitly. So we've got x squared plus y squared equals 25. And we want to derive this or differentiate with respect to x, which is what we did in all of the last chapter on the rules. Everything we derived or differentiated was with respect to x, and unless it was in the case of a word problem, and then sometimes it was in terms of time, okay? But, okay, so based on what we know, the derivative of x squared with respect to x would be 2x. I'm going to leave some space. And the derivative of 25 with respect to x would be 0, okay? But what do we do with the derivative of y squared with respect to x? Okay, so if you remember back to when I first introduced you to all the ways we could write what the slope of the tangent was, we could write m tangent, y prime, f prime at x, and then there was this Leibniz notation, dy by dx, and that's the one we're going to use when we're implicitly differentiating, just because it stands out. The other one that's often used is y prime, but it's harder to see. So we're going to use this dy by dx. Okay, so this means the derivative of y with respect to x. That's what dy by dx means, derivative of y with respect to x. So in this case we want the derivative of, well, it's not y, it's y squared. So I'm just gonna, that's what we're taking the derivative of with respect to x. Okay, so just as an aside then, before we go back over here, we can use the chain rule to figure out the derivative of y squared with respect to x. So if you remember back, when we first learned what the chain rule was, we said dy by dx was the same as dy by du times du by dx, okay? But in our case, we're gonna have our y be our u. So we're gonna do the derivative of y squared with respect to y times the derivative of y with respect to x, okay? And you can think of like these dividing out, and then you're left with the derivative of y squared with respect to x, okay? But this dy by dx is really important because it is y prime. It is the slope of the tangent, okay? It's what we're trying to find. It's the slope of the tangent, which is what we're trying to find, or it is y prime, it's what we're trying to find. So if we derive y squared with respect to y, we can just use the power rule. It's 2y. So the derivative of y squared with respect to y as our variable would be 2 times y to the power of 1, which we don't need to show. But I still have to multiply that by dy by dx. So instead of writing times dy by dx, if you just write them side by side, that means that the derivative of y squared with respect to x is 2y times the derivative of y with respect to x, or times y prime, okay? So if we go down here, we have 2x plus the derivative of y squared with respect to x we said was 2y times dy by dx equals 0. Now dy by dx is y prime, or the slope of the tangent. That's what we're trying to find. That's what we want to get by itself. So to do that, we could subtract 2x from both sides first. And we get 2y dy by dx equals negative 2x. And still, it's dy by dx, which is the slope of the tangent, or y prime. They all mean the same thing by itself. So we're going to divide both sides by 2y. And we get that dy by dx, the 2's divide out, ends up giving you negative x over y. Okay, so that is the slope of the tangent, y prime dy by dx. Okay, but we want to know what's the slope of the tangent at the point 3, negative 4. That's what the question asks for. So we can say that dy by dx at the point 3, negative 4 is, so this is x and this is y, negative 3 over negative 4. So, and that reduces to 3/4. So therefore the slope of the tangent would be 3/4, which is what we got just using geometric properties. Okay, so this was using implicit differentiation. This is using geometric properties. They match. And there was an example of using implicit differentiation. Okay. So we're going to do a bunch of examples until we get good at doing this as well. First, we're just doing another simple question here. What is the derivative of 3y squared with respect to x? And it reminds us to use the chain rule. So the derivative of 3y squared with respect to x is the derivative of 3y squared with respect to y times the derivative of y with respect to x, which is going to be, so the derivative of 3y squared with respect to y, we can use the power rule, so it would be 2 times 3 is 6y to the 1 times dy by dx, and don't use the times sign because it just you can mix it up with an x. So this means 6y dy by dx, all three things multiplying together, 6y and dy by dx. So that's the derivative using the chain rule. So the steps for implicit differentiation. So again, what are you looking to do? You're trying to find the derivative. Okay, remember dy by dx stands for y prime. It stands for f prime at x. It stands for the slope of the tangent. Okay, we still want to find the derivative. This is just a way to do it using implicit differentiation when the x's and the y's are mixed together rather than having y on the left side and everything else in terms of x on the left. So our steps are differentiate both sides with respect to x. Remember that you have to use the chain rule for terms containing y. And remember that differentiating x times y would involve the product rule because we have two functions multiplying together, a function of x and a function of y. So then after we've done the differentiation, the next step is to get dy by dx by itself using algebra. So for example, or i.e. you want the terms that involve dy by dx on one side of the equation and the terms that don't on the other. Okay, so we'll go through some examples here. So differentiate implicitly, our first question. So again, we're deriving with respect to x. So the derivative of x squared with respect to x is 2x. The derivative of 4y squared with respect to x. Okay, so this involves the chain rule. So first we're going to derive it with respect to y. 2 times 4 is 8y. And then times, because there's a chain rule involved here, the derivative of y with respect to x is equal to the derivative of 36 with respect to x, which is 0. Okay, so that step was kind of our calculus step. Now we want to get dy by dx by itself, because that represents the slope of the tangent, or y prime. We want to get it by itself so we know what y prime is. And this time it's going to be in terms of x and y instead of just in terms of x. So reverse BEDMAS we can use because dy by dx is only in our one spot here. Subtract 2x on both sides. And then divide both sides by 8y. So the slope of the tangent at a point xy is going to be, you can reduce that if you like, negative x over 4y, because we could divide top and bottom by 2. Okay, so the slope of the tangent at any point on the curve x squared plus 4y squared equals 36 can be found if you know the point. It would be negative x over 4 times y. All right, the next one. So starting off here, we've got x times y, and that's a product rule. So when you have a product rule, you've got to set up your little chart. First, second, function, derivative. So my first function is x, my second function is y. So the derivative of x with respect to x is 1. The derivative of y with respect to x, so imagine this again, we've got y to the 1. If we use the power rule, it's going to be 1 times y to the 0, and then because it's the chain rule, times dy by dx. But y to the 0 is 1, so the derivative of y is dy by dx, or the slope of the tangent. Okay, so according to the product rule, derivative of the first times the second, so 1 times y is y, plus the first times the derivative of the second, so that's x times dy by dx. So that's this part here. They correspond, so x times y, the derivative of x times y is y plus x times dy by dx. Now plus the derivative of y cubed with respect to x. So that's going to involve the chain rule. So the derivative of y cubed with respect to x is going to be 3y squared times dy by dx. And that's going to equal the derivative of x squared with respect to x is 2x, and the derivative of 1, any constant, with respect to x is 0. Okay, so now we want to get dy by dx by itself using algebra. So I'm going to keep these terms on the left and subtract y on both sides, so that the terms that I have on the left both contain dy by dx, which is what I'm trying to find. Okay, so I want to get dy by dx by itself, so I can common factor it out of the terms that are on the left side. So if I divide x dy by dx by dy by dx, I get x. And here I get 3y squared. And it's dy by dx that I'm trying to get by itself, or the derivative, y prime, that I'm trying to get by itself. So I'm going to divide both sides by x plus 3y squared. And that's going to give me y prime, or dy by dx, is equal to 2x minus y over x plus 3y squared. Okay, again, that means the slope of the tangent, or y prime, is equal to 2x minus y, all divided by x plus 3y squared. C. So again, 2xy is going to be a product rule, so 2x multiplied by y. So we'd have to make a first, second function derivative here. So my first function is 2x, and my second function is y. The derivative of 2x with respect to x is 2. The derivative of y with respect to x is dy by dx. So we're doing a product rule there. So derivative of the first times the second is 2y plus 2x dy by dx minus, so derivative of y cubed is going to be 3y squared times dy by dx using the chain rule, and the derivative of -4 is 0 equals 0. So now I'm going to get dy by dx by itself using algebra. So first I'm going to get rid of the -2y by subtracting 2y on both sides, so that I'm just left on the left with terms that contain dy by dx. And then I can common factor dy by dx out of the terms that contain it. Divide both sides by 2x minus 3y squared. And I get that the derivative of y with respect to x, or y prime, is equal to -2y divided by 2x minus 3y squared. Okay, and D, so 3x y squared is going to be a product rule again. So the first is 3x and the second is y squared. The derivative of 3x with respect to x is 3. The derivative of y squared with respect to x is going to be 2y times dy by dx. So when I derive, I'm going to get 3y squared plus, so careful here, 3x times 2y times dy by dx is going to be 6xy. 3 times 2 is 6 times x times y, dy by dx, plus derivative of y cubed is going to be 3y squared dy by dx, chain rule, equals 0, because the derivative of any constant like 8 is 0. So going to keep the terms with dy by dx on the left, subtract 3y squared on both sides, 6xy dy by dx plus 3y squared dy by dx is equal to -3y squared. I'm going to common factor dy by dx, and I'll get 6xy plus 3y squared. Divide both sides by 6xy plus 3y squared. And we get dy by dx equals -3y squared over 6xy plus 3y squared. And you may see that like I could factor out 3y in the denominator and divide it out, but that's not a big deal with implicit differentiation. Usually we're doing it in order to substitute in a value and find the slope of the tangent. So reducing is, you don't have to really worry about that for implicit differentiation, especially in grade 12, okay? And even if you had this question in first year and it was multiple choice, you'd be able to divide top and bottom by 3y and realize that you had the right answer and pick out of the multiple choice answers which one was yours. Okay, next one, x cubed y to the 4th equals 3. So we've got a product rule here. So x cubed is the first, y to the 4th is the second. Derivative of x cubed is 3x squared. Derivative of y to the 4th is 4y cubed times dy by dx. Product rule, so derivative of the first times the second, that's going to be 3x squared y to the 4th. And then plus the first times the derivative of the second, so I'd probably write it as 4x cubed y cubed dy by dx equals, and then the derivative of 3 is 0. Subtract 3x squared y to the 4th from both sides. Oops. 4x cubed y cubed dy by dx is equal to negative 3x squared y to the 4th. Divide both sides by 4x cubed y cubed. And we get that the slope of the tangent y prime dy by dx is going to be negative 3x squared y to the 4th over 4x cubed y cubed. Okay, so find the slope of the tangent to the curve 2x squared plus 3y squared equals 5 at the point 1, 1. So find the slope of the tangent to that curve at that point. So first, we would need to find dy by dx, and then find dy by dx at the point 1, 1. So the derivative of 2x squared with respect to x is 4x, plus the derivative of 3y squared with respect to x is going to be 6y times dy by dx, according to the chain rule, equals the derivative of 5 is 0. We want to get dy by dx by itself. Divide both sides by 6y. And we get that dy by dx is equal to negative 4x over 6y. Again, you could divide top and bottom by 2 if you want to, if you think it makes it easier, but you don't have to. And then we want to find the slope of the tangent at the point 1, 1. So we're finding dy by dx at 1, 1, which is going to be negative 4 times 1 over 6 times 1, which is negative 4 over 6, which is negative 2/3. So therefore, m tangent equals negative 2/3. Okay, next question. Find the slope of the tangent to the curve x plus y all cubed equals x cubed plus y cubed at the point negative 1, 1. All right. Okay, so x plus y all cubed. So this is when we derive it, chain rule. 3 times whatever's in the brackets, x plus y to the power of 2. And then we want to multiply by the derivative using the chain rule of what's in the brackets. So here's my bracket. The derivative of x is 1. The derivative of y with respect to x is dy by dx. Okay, So that's the left side. The right side, the derivative of x cubed is 3x squared. The derivative of y cubed with respect to x is 3y squared times dy by dx. Okay, so this one's going to be a little more complicated to get dy by dx by itself because it's on both sides of the equation right now. All right, so we can use the distributive property to multiply this by each part of that. So only one of them will have a dy by dx attached to it. So if we do that, we get 3x plus y squared times 1, so that's just 3x plus y squared, plus 3x plus y all squared dy by dx. So I want to get the terms with dy by dx to one side, so I'll bring them to the left side, and I'll bring the terms that don't have dy by dx to the right side. So I'm going to subtract 3 times x plus y squared, all squared on both sides. And I'm also going to subtract 3y squared dy by dx on both sides. So those are gone, and those are gone. So on the left, I'm going to have 3 times x plus y all squared dy by dx minus 3y squared dy by dx. And then on the right side, I'm going to have 3x squared minus 3 times x plus y all squared. Okay. So now I want to get dy by dx by itself, so I'm going to common factor dy by dx on the left side, and that's going to give me 3 times x plus y all squared minus 3y squared. And then I can divide both sides by 3 times x plus y squared minus 3y squared. So I've got dy by dx, and then let's put it already at negative 1, 1. So remember, that's x, that's y. So it's going to be 3 times negative 1 squared minus 3 times negative 1 plus 1 squared over 3 times negative 1 plus 1 all squared minus 3 times 1 squared. Back up to here, so dy by dx at the point negative 1, 1 is equal to, so that's going to be 3, negative 1 plus 1 is 0, so minus 0, so 3, over negative 1 plus 1 is going to be 0 over negative 3, which is equal to negative 1, so therefore the slope of the tangent is going to be negative 1. Okay. Last question, find the equation of the tangent line to the curve x cubed minus 6xy minus 2y cubed equals 0 at the point 4, 2. All right, so we've got our derivative of x cubed is 3x squared minus, but then to derive 6xy we have a product rule. And I'm going to put the results of the product rule in square brackets because we're subtracting the derivative of 6xy. So first, second function derivative. So our first is 6x and our second is y. Derivative of 6x is 6. And the derivative of y is the derivative of y with respect to x. So we're subtracting derivative of the first times the second plus the first times the derivative of the second. And then we still have to derive negative 2y cubed. So using the chain rule, that's going to be negative 6y squared dy by dx equals 0. Okay, so then expanding out this negative, we're going to get minus 6y minus 6x dy by dx minus 6y squared dy by dx equals 0. So normally I keep the dy by dx terms on the left side, but since I see they're both negative, I think I'm going to bring them to the right side instead to make them positive. So now I've got 3x squared minus 6y on the left and 6x dy by dx plus 6y squared dy by dx. And then on the right, I can common factor out dy by dx. And then divide both sides by 6x plus 6y squared. And then I've got dy by dx by itself. So dy by dx is going to be 3x squared minus 6y over 6x plus 6y squared. And they want the equation of the tangent line this time, not just the slope, but in order to get the equation, we need the slope at the point 4, 2. So that's going to be 3 times 4 squared minus 6 times 2 over 6 times 4 plus 6 times 2 squared, which is going to be 48 minus 12, so 36 over 48, which top and bottom are divisible by 12. So that's going to give me 3/4. So that means M tangent is 3/4, and we know we have the point 4, 2 for x and y. So we can use y equals mx plus b, with y being 2, m being 3/4, x luckily being 4. So that's going to give me 3 and a b of negative 1. So therefore, equation of tangent line is y equals 3/4 x minus 1. All right, so our success criteria are that we can differentiate a function implicitly, we can find the slope of the tangent to a function that is defined implicitly at a specific point, and we understand that the derivative of 2xy is 2y plus 2x dy by dx using implicit differentiation with the product rule. So whenever you see a function of x and y, you realize that you have to do the first, second function derivative. So 2y plus 2x dy by dx using the product rule. Okay.